Hi, our project is Elderly Living Alone Health Monitoring System. We have 5 team members. In this presentation, we want to introduce our project in 4 parts. The first one is background, the next one is voice part, and then the image part, and the last is complexity. The first one is background. In the background, the US Census report from 2014 project that by 2050 the 65 and older population to be 83.7 million, almost double the 2012 estimate of 43.1 million. New 2015 US Census data also reflects more elderly who live alone. 42.8% of those 65 and older. According to the report of New York Times, Japanese made the statistics in 2017 that 4,000 people living alone passed away every week, which reaches Japanese society. By the end of 2016, the elderly population in China aged 60 and over has reached 230 million, accounting for more than 16 of the total population. Meanwhile, the elderly living alone in China has approached 100 million people. We think that artificial intelligence can help elderly living alone to have better and safer life. To improve the quality of life of elderly living alone, we designed our system, which is called Elderly Health Monitoring System. In our system, it can collect and analyze data to understand the mental and physical status of elderly and then make feedback. If they need some help, this system will give them some kind of mental care and health suggestions. Besides, this system can recognize situations such as fall down, long-term disappearance, and then take emergency measures to ensure the safety of these old people. Then, why our project is artificial intelligence? First, we know that the realization of artificial intelligence needs sensors to collect data. In our system, we added some sensors to receive the audio information and the monitoring cameras sensors to receive video information. Second, the artificial intelligence system should have the ability of understanding data and reasoning in our system. We deal with this data in artificial intelligence module to figure out proper responses. Then the voice part. At first, I want to talk about user story. As an elderly living alone, I want to ask to help anytime to avoid danger. I need the voice assistant like call 911 or ambulance phone for help. As an elderly living alone, I want to chat with someone to relieve boredom or get some information like news from the voice assistant. As an elderly living alone, I want to be concerned when I was depressed. The general of the model. In speech recognition and processing is an important part of our intelligent system. Although, to some extent, the use of voice assistants in public is awkward. It can be well used in private indoors, especially for elderly living alone. For example, many elderly people have problems with their eyesight. Using voice assistant can help them accomplish some tasks without looking at the phone screen. The voice function can also provide good help for security issues that our project is more concerned about. We use far-field microphone array to detect the voice information, then use DN to analyze the information and generate output. We will discuss these topics in details in next section. The microphone array. We will use microphone array as our sensor to collect voice information. It will help us inhibit the generation of noise in information collection part. The microphone array is a set of microphones arranged in specific geometric structures and capable of obtaining accurate spatial information through the arranging relation thereof. The spatial filtering-based beamforming techniques utilize the spatial characteristics of the microphone array, so that the array beam is directed towards the target sound source, and zero slots are formed in the noise direction, which suppresses the noise intensity to some extent while highlighting the sound source information. In memory part, we want to use WAV files. The WAV files format is an important digital audio file format, and it is an audio format that is currently widely used. WAV files do not use compression technology, and therefore their files are much larger. When we perform speech recognition, the interception time will not be too long. Therefore, there is no requirement for the file size to be too high, and the file capacity can be acceptable when it is stored. Since compression techniques are not used, the sample date of the sound in WAV files can be easily read out, and it is easy to do other processing. In this part, we have 6 DPs and 11 FRs in voice part. The details and the integration with image part were shown in the paper. The next is image part. First, we need to think as a real participant in this system. As an elderly use system, I want to get the condition of my health and help me call for help when emergency happens. As a developer, I want this system to attract users to help us collect data and to make the database more complete. As a relative of the elderly, I want to get informed when emergency happens so that I can take care of them even I am out around them. From what I need based on the function of our artificial intelligence, except the voice, we also need to graph to analyze. Graph is true reflects the current situation. It is accuracy to verify the body and mental health through images. Because our target group, the main function based on the image is divided into 2 concepts. Using facial recognition technology to recognize the features on the user's faces. It identifies the emotion and body condition of users to provide professional advices. Using human behavior recognition technology to monitor the elderly. Detect the send information at the same time as the emergency happens. Aim at the first fake function. What we usually use as sensor is the camera on the phone. Because of its convenience, users can use and verify their body condition at any time or places. The other way, we need to high precision visual sensors help. In the following part, we may introduce the sensor separately. The mobile phone camera as the main sensor, imaging with a photosensitive device. There are 2 main types of CCD and CMOS. They all consist of semiconductor memory, which is high photoreceptor. They can transfer the light into electric charge, then replace the digital signal by a digital converter and upload it to a system. Different from the need of face recognition, to realize the monitor behavior, we may need high-level visual sensor. Mainly, it consists of camera to capture and controller that handle the image. Aimed at tracking customers. We may also need AVA image tracking system to keep the customers in the center of our image to avoid the fade zone. The first function relies on face recognition technology. Nowadays, some popular software which used to do face recognition like Orbi, which developed by MIT, or face recognition from Lambda Labs. This excellent software can identify the details on people's faces. The process of our system like this. At the start, we establish database which contain the condition of different parts of face relation to body hairs, and each expression related to the emotion. Then we get face information from mobile phone's camera. The analyze and recognize features from particular parts of face. Based on features, shows the corresponding information of body hairs. Then search for hairs device advice and apply for user. For the next function, human behavior identification. This is also one area in artificial intelligence for a long time. It is one technology in the application of intelligent monitor and human-computer interaction. It sets key points on people's body and identify the behavior from the move of points. We use RGB image to do pose estimation, or we can use deep camera to get it directly. Every time sequence consists of framework corresponding to key points of location information. The time sequence consists of many frames. Behavior recognition is the type of behavior action that is determined by the sequence of the time domain precard. That is, read the behavior. Recent research of behavior identification concentrates on the research of errorship. We explore the invariant of body deflection. Envelope shape means the outline which is a little larger than the real people. When the body spin, envelope shape has little change of it. So based on this, we can collect data and do the training and identify the behavior with high accuracy. The last is complexity part. In this part, we will mention some of the DPs and FRs of image part. This is our design matrix. All of the DPs and FRs are in this matrix. The real complexity. Time independent real complexity is related to the uncertainty that arise from the random nature of the system. Volume of historic data is not very much because of our design. We just store the future state. The storage of photo is not very large, and we will delete the used photo sometime later. Volume of ingested data is not very large. The ARM terminal of the system would cut and compress the useful photo. For the face portion, there is only 1 MB for every picture. For the behavior picture, there is only 6 kilobit to 8 kilobit per 1 minute. It is just a little data for the internet bandwidth, but we design this system more AI to figure out if the human is moving and activity. When the human is moving and active, the camera uploads the photos every 1 minute. But when the human sleeps at night, there is a few actives. The system only catches and uploads photos every 10 minutes. Number of concurrent users, we cannot know the certain upload date anytime. The strength of the server is unknown. It depends on the analysis probability of service. For example, if the service could analyze one picture in 1 second, the service would load 180 users easily. The photo upload error between internet, the data might be damaged by complexity internet environment. It is also uncertain. Imaginary complexity. Lack of knowledge, ignorance of the emergency of some behavior not easy to detect. Many behaviors are caused by different diseases. Because of the lack of knowledge, it is impossible to match the behaviors with the real status. The solution is to network the hospital's database with our design system, but this will also cause the database to be too large, causing excessive pressure on the server. Of course, there may be complexity that other knowledge does lead to. The subsequent experimental verification is required to obtain reliable results. Lack of knowledge required to synthesize of the identified problem will increase the uncertainty. This type of ignorance can be due to the sheer absence of technological expertise in particular subject matter of inability to predict emergent effect when a particular solution is implemented. Oftentimes, advance in technology resolve the problem. The uncertainty caused by the above is not inevitable and thus imaginary. Combination complexity. As time goes by, the data of collection will increase and the time of comparison picture would increase. The result of voice and picture might have some differences. The conflict might cause the crash of the system. The complexity of data mixing. There are multiple cameras in our room. How to interpret the data of each camera is not an issue. It's an important issue. We are creating the multi-camera scenario real multi-target tracking problem by adopting relative algorithm from RAID as well as useful control system tools. Periodic complexity. The apparent periodicity can be defined by system ranges behavior. Time-varying system range changes and deviate from its initial design distribution, decreasing probability of success. The solution is to form memory learning based on the user's behavior. The amount of work in the early period is slightly large, but once a fixed pattern is formed, a burden of server and system will be greatly reduced. That's all. Thank you.